Hey guys!
Good morning. So we're going to have some fun now. This section is divided into 2 days. However, the notes you printed out are for both lessons. So we're only going to do part of them today. So don't lose your notes because you're going to need to do it for the next lesson. The explanations, the examples they're intense. Okay, just strap in and here we go. In Section 8.1, you learned how to solve trigonometric equations graphically, and now you can see that what we have here is a graph, and obviously we are going to look for the solution. We're going to look for these 2 points here, but we're going to do this without the calculator. Now, we've shown you the graph because we want you to be able to figure out how to find these numbers algebraically, because we're getting ready to go to problems where you don't use the calculator, and you need to understand this. All right, so first thing we did, as you can see, F1 is our cosine graph, F2 is our negative 0.2 graph. Now, here's what we want to look at. Let's pretend you don't see the graph. Let's look at this equation. You can see that the cosine of our angle is negative. Now, where is cosine negative? In quadrant 2 and in quadrant 3, right? Well, if you were to go to the calculator and say, give me the answer where this is negative, what's going to come up on the calculator? You're saying basically, hey, calculator, tell me the angle whose cosine is negative 0.2. Okay, last class we talked about what that meant. Here's what's going to happen. You're going to get the calculator, it's going to say, look, your angle, the radian measure is 1.772. Well, that is this angle right there. That's at 1.772. Now, if you don't have your calculator open, where you're looking at the graph, and again, we're getting ready to go to ones where you don't use the calculator, you can see clearly there is another angle where this is going to also happen. If we think about the unit circle, we know that our angle could be here. So 1.772, pi over 2 is about 1.57, and pi is about 3.14. So we can see that 1.772 is about right there. It's going to take us to there. Okay, so that angle is this one in radians, but you know that we can also go this way. And what was one of the things we learned about cosine? Cosine is an even
function.
Yeah, so there is another angle, and guess what? The other angle is negative 1.772. Now, the other question we have is, well, in our window here, we've only sketched pretty much one cycle. We only see from here to here, so that's one cycle of this function, but we know that our functions go on and on and on forever. They are continuous. So we know that this little intersection that happens here is going to happen. Notice that is on the upward side of the curve, so it's going to happen again. If we look at the graph of cosine, it's going to happen here, and it's going to happen here, and it's going to happen here, and it's going to keep happening in all these spots. And this zero here, or this intersection here that's on the downward side of the curve is going to happen here, and here, and here, and here, and all of that. What do we know about cosine?
Has a period of 2 pi.
So the way we answer this question is approximately plus minus 1.772, 1.772, and every 2 pi after that. Now, there's another way to visually understand this, and that is if you look at the circle. Here is the first place with one rotation. That we have 1.772. Guess what? We can go around it a whole nother time. There's another place, and around it a whole nother time, and so forth. And we can do the same thing going in the negative direction. We can go here, and around, and around.
Okay.
So, what are the concepts we used? We used the fact that cosine is an even function. And so that means that the cosine of a negative angle equals the cosine of the angle. So that was how we came up with our second angle. We'll have to be able to do this without a calculator. Here is our answer. Well, you wouldn't be able to get that 1.772, but if we used a value, say like -1/2, that's a unit circle value. So that's where we're going with this, okay? You may need to replay this to think about it again, because the next one we're moving to is sine, and since sine is an odd function, it's got a slightly different concept that we use.
All right. Okay, so now we're going to look at solving sine equations. All right, we know that sine, okay, here we're looking where sine is a negative number. Well, we know sine is negative in the third and fourth quadrants. So sine is of x is less than 0 in quadrant 3 and quadrant 4. Okay, well, over here, if we were looking at it graphically, we can see that our solutions are, let's see, we have one right here, and we have one right here. Okay, well this part, we also have one way over here. This one would be the one in quadrant 4, okay, where it's a positive angle. This one over here would be quadrant 3. This one over here would also be in quadrant 4, but this is the negative angle.
Okay, so we were going around in the negative direction.
And here's the thing, which one of those do you think your calculator is going to give you? This
Well,
is where our lesson from yesterday is really important, because there's a whole lot of answers here, but the calculator is only going to give you one.
So the calculator is only going to give you between negative pi over 2 and pi over 2. It's not going to give you, remember we talked about it gives you stuff in quadrant 1 and 4 for sine, and this one, so it's only going to give you the stuff from here to here, so this is the value that it's going to give you on the calculator. So this is the one that's going to tell us where it is on the, in the solution set for that.
okay, so
Let's see, when you plug it into your calculator, you would do x equals, we're looking for the angle, x is an angle, so we're going to use sine inverse of negative 0.33.
Okay, remember that we read that. The angle whose sine is negative 0.33. Okay, the angle whose sine is, so we know we're looking for an angle.
Okay, so the angle whose sine is negative 0.33 is negative 0.336. So this value, this x value right here is negative 0.336. Okay, so for this solution, it repeats itself here and over here, if we looked at it that way, and it keeps repeating itself. The sine, the period of sine is 2 pi, so it repeats itself every 2 pi units. So for this specific one, all right, we're not talking about this red dot I'm putting on right here. We're not talking about that one. We haven't talked about that one yet. But for x1, negative 0.336 plus 2 pi k is the set of solutions for that one. Now let's look at, to find the second angle, the red one that we have.
While she's talking about that, I'm going to draw a unit circle. Okay, that works. It's a red one. And what did we just find? We just found this one.
The negative angle. Remember, it's negative.
So we know there's one over there. We know there's one right here. Okay, go ahead.
Okay, and all right. So to find the second angle, we have to use. Notice that this right here is pi. Okay, that's 1/2 rotation around a circle is pi.
Well, that's negative pi. Pi is,
Well,
yeah,
okay,
yeah.
It's a distance of pi.
Right, exactly.
And if I want to know what, okay, there we go. All right. Okay, so here we have pi, and we're going to essentially add this piece right here, because this is negative, a minus, a minus. Okay, so we do pi minus the angle, and that angle is, the angle is negative 0.336 radians. So x2 is, when we take the sine, well, this is the angle, so
just do,
this
yeah,
is
pi minus
just
the angle. Pi minus x I would do.
pi minus
X, just write x. And
x1 plus 2 pi k. Okay, so this is the formula right here. We don't want you to memorize it. We want you to understand what it's saying. Okay, this is the second angle is pi minus the first angle plus the 2 pi k because it's going to rotate around and again come back to this point every 2 pi units. Okay, so x1 was this stuff right here, so we're going to have x2 equals pi minus negative 0.336 plus 2 pi k. So let's see. That is, if you plug it into your calculator, this is 3.14159 something, okay? So when you add them together, you get approximately, we're going to put approximately, because all of this is approximations, 3.478 plus 2 pi k. That's x2. Okay. So this is tricky because sine is odd. Okay? Now, another way you can look at this is since sine is odd, okay, the sine of negative x equals negative sine of x.
Mm-hmm.
So,
if our x is if our x was negative, this is negative 0.336, so the sine of the negative 0.336, that's this part. The negative of that, okay, we don't want to explain it that way.
yes.
Erase, redo. So, the sine of the negative of some angle, and our angle is negative 0.336, would equal the negative sine of that very same angle. Notice all I've done is, instead of x, I've put in what our x was. Okay? Well, it turns out that the sine of 0.336 would equal the negative sine of negative 0.336. Well, the sine of 0.336 is, well, where's 336? That's right there, 0.336. Do you see that the sine value here is positive? And then, over here, this is odd functions. Basically, if you have part of it graphed in quadrant 1, if it's an odd function, it'll show up in quadrant 3. So that is your, right here, negative angle. So that is the negative sine of the angle. Now, this is hard to understand here, but here's the key point is this. If we have an angle that shows up and we do our little calculator thing and we get some angle in quadrant 1, okay? Because our sine, let's pretend we're looking at a sine that value that's positive. Do you see that we also have that very same angle? That sine value would happen in quadrant 2. Well, how would we get to this angle here? Well, we're using reference angles. This right here, let's make that a reference angle T prime. And this right here would be our reference angle T prime. And how would we get to this right here? We would do pi minus T prime, our reference angle. And guess what? That's what we did right there. Okay, so you're using the reference angles. It's complicated. It's a lot easier when your sine value is positive. It's easier to see, but that's what's going on. So what we had right here is our reference angle of negative 0.336. This angle that gets us here is our reference angle of 0.336. And how do we find out what this point is right here? The sine, to find this point, it was pi minus that reference angle, which the actual angle itself was negative. So we're going to add pi plus our reference angle. That's what we did. Okay, we really used reference angles. Okay. Tangent is an odd function.
And when tangent, this is saying tangent is negative. So when tangent of x is less than 0, we're looking at the second quadrant and the fourth quadrant. All right.
Yeah, so let's just draw a circle. Let's draw a unit circle and get a visual idea of what's going on here. Okay, so which answer is the calculator going to pop out at us before we ever do this? Which we should already know which one we're going to get. Okay, what's our interval for tangent? Negative pi over 2 to pi over 2, right?
Mm-hmm.
And so from here to 0 is quadrant 4. And from here to 0 to there is quadrant 1. So which quadrant is the calculator going to pop out at us? Yes. Okay, so what we have is some angle, and we're going to find the tangent value. We're going to plunk it in on the calculator. We're going to write x equals the angle whose tangent is negative 4, and the calculator gives us plop negative 1.326. So
Okay,
let's find
so
that.
That's about
Let's see, negative, it's probably negative around there somewhere. Yeah, there we go. All right, so we have that point right here on the circle. Well, where else in our circle would we have that same point? Well, the same value for tangent, up there. All right, so how could we give our answer?
well, since it's odd, we're doing the same type of thing we did with sine. This is our reference angle t prime. This again is the same reference angle t prime. So we're going to do pi minus t prime to get this thing.
Yeah.
Okay?
Okay.
So that would be,
well, let's see, our reference angles, remember that reference angles are actually always positive. So our angle here was negative 1.326. That is the angle that gets us there. T prime would therefore be 1.326. Okay, that's our reference angle there. So what would that angle be way up there at the other dot?
well, that would be x equals
3.15,
3.14
4, 1.516.
over
2.
2.
Yeah, minus. Minus. We. That's okay.
That's what was it, 6?
1.326. Yeah.
All right, minus 1.326.
Okay.
Plus 2 pi.
Well,
Okay.
Oh, wait!
no!
Period of tangent
Whoa!
is not 2 pi!
Period is not 2 pi. Oh, Mrs. Meller's just about.
It's in the morning, you can
It's
tell.
pi k. All right, because the period of tangent is pi. All right, because look at this. The distance from here to here. Well, anyway.
Yeah. But you want to know what's funny about this one?
This one right here is one iteration.
Yeah, so really, this one, what we could have answered on this is just negative 1.326 plus pi k. But why do we want to know how to actually do this part? What would that be? 2 minus 6 is 6, 3 minus 2 is 1, right? 1 and 8, right? And 1. Which makes sense. That is in quadrant 2, okay, because 1.57 is pi over 2. Why would we want to know how to do this? Well, what if you were asked to give only the quadrant 2 angle? Then you'd have to know how to get there, and the calculator is not going to give you that angle. The calculator is only going to be programmed to give you that quadrant 4 angle. That's between negative pi over 2 and 0. So you have to understand what is going on here in the circle so you can visualize where you are and where you need to go. That is what makes this tricky, tricky, tricky. Okay? And now we can confirm over here on our graph. Here is our answer right there that got popped out at us. You can see that this is negative pi over 4 right here, so this is negative pi over 2, and that definitely does fall in the interval between negative pi over 2 and 0. So, our real answer for this problem is this. This answer covers all the bases that we need. It gives us this one. When we add pi to it, it's going to get us over here, and what do you think that number is? It's going to be that one, and so forth. So that is what we're looking for. Now, you don't always use the reference angle in every single problem. We know there is some confusion about reference angle. Let's remember what reference angles are. Reference angles are acute angles, meaning if you're in degrees between 0 and 90, and if you're in radians between 0 and pi over 2 or 0 and 1.57. And we use reference angles all the time to find other angles. And in this problem, we didn't have to do it, but we could have taken the absolute value of this and subtracted it from pi to get that angle that takes us to there.
So let's
visually,
discuss.
reference angles are very important to understand for where we're going as we move forward.
Okay. Oh, the big yellow box could be of use to you on page 540 if you need more steps to learn how to solve these.
And we're trying to teach, okay, oh, there you go, there's some ET problems.
All right, ET problems. There's 3 because this one is a cosine, I believe. This one's a sine, and this one's a tangent.
Something
or
like that.
Something like that. Okay.
You got one of each.
Yeah, one of each. So just rewind and pause and
yeah, and do
whatever
them like we did them. If you want to graph it to have a look at it, you can. But what is more important is when you draw that unit circle and you put the point on the circle and you think about where it is and where you need to go. Okay. All right, so now we're moving to problems where we have calculator issues. This one's actually going to use a calculator because it's not a special value. So we would do what?
Well, first we need to go ahead and solve just like we would in a situation with a function inside, like a logarithm or a exponential. We solve for the function. So we need to get the function by itself. So first I'm going to subtract 1 from both sides. So let me go ahead and rewrite the problem. We've got 3 cosine of x plus 1 equals 0. So subtract 1 from both sides. Okay, subtract 1, divide by 3. You get cosine of x equals negative 1/3.
Ooh, cosine is negative. What
Where would that be?
What quadrant could our answer be in?
All right, that would be in 2 or 3. So cosine of x is negative when we're in quadrant 2 or 3.
But what calculator answer are we going to be given?
2.
Because our interval for cosine is 0 to pi. And if you break that down, 0 to pi over 2 for when cosine is positive, and pi over 2 to pi for when cosine is negative. Okay? Important. So we are only going to get one answer. We're going to get this one popped out at us. We might, for some reason, need to know the quadrant 3 angle, and this is where reference angles come in.
So let's draw the angles that we're looking at here. All right, negative 1/3.
Well, we need to find the angle
We
is
need to
cosine.
find x equals. The angle is
The angle whose cosine is.
whose cosine is negative 1/3. There we go.
And it's really important to put those things in parentheses, okay? Because otherwise it looks like something stupid.
Okay, so let's see. In here we've got about right.
Well, when we pop it on the
when
calculator, we
plug
get...
it on the calculator, we get x1 equals 1.911 plus 2 pi k.
Of course, the calculator doesn't give you the plus 2 pi k, but if you see it on the circle, you can see it's going to happen every time we rotate around the circle, one full revolution.
So this is 1.54, what is it?
That's 1.57.
1.57.
And there's 1.9.
So this is 3.14. So this right here is about 1.9.
Mm-hmm.
Okay, so this is where we're looking at. So if we wanted to rotate it over and over again, that's where we would get our 2 pi k. Okay.
And now...
Now, since cosine is even, it's going to be... Whoops.
We're going to
Okay.
put it right.
So we're going to put it right here. I need a different one.
Yeah.
Right there. Okay. And so what we're going to do is we've got x2, since it's even, is going to be the negative of the x1. So negative 1.99. 1.911.
Too many numbers.
1.911. Okay. Plus 2 pi k. Now we could write this as one solution as x equals plus or minus 1.911 plus 2 pi k.
And if we, for some reason, guys, wanted to know what the angle going to this is, how would we do that? Well, we have pi plus...
The reference
the
angle.
1.9.
No. The reference angle is this piece right here.
Oh, shoot, dang. So we'd have to find the reference angle. Okay, that's a lot of work. We could also do, look at that negative. We could do 2 pi and add that negative. But either way, so we know that that number is going to be between... We know that number is going to be between 3.14 and 4. This is 4.71. So You can take 6.28 something and subtract 1.91 something, and we get what? 4.37, which makes sense because look where that is. That would be a quadrant 3 angle.
If you want any angle, all you have to do from those two spots is add or subtract 2 pi. That's what this is saying right here. Add or subtract 2 pi from these two to get you all the different choices you've got. Okay?
Yep. Okay, so now we're going to go to one that doesn't use a calculator because I hope you recognize that that one right there is a unit circle of angle. So first of all, we know that the sign of our angle is positive, so we know that sine is positive in quadrant 1 or 2, but our calculator is, if we used it, was only going to pop out one answer, but we're not going to use the calculator. So what do we know? We know, here's a u. Oh, I should have used u here. Okay, so u is the angle whose sine is 1/2. Well, we know what angle that is. Let's see. The y value is 1/2, so that makes it a 30, 60, 90. So my y value is 1/2, which we know then that the x has to be square root of 3 over 2. And what angle is that? Well, u is pi over 6. And if you think about what's happening on the circle, every time we go around one full revolution, I'm going to hit that value again. But there is another angle, and that's one over here where we use that pi over 6 as a reference angle. That's what we're talking about with the reference angle. And where are we right here?
Well, that's going to be 5 pi over 6, or 1 pi minus pi over 6.
And the thing about this is the way we're going, we want to give, this right here doesn't give every single answer. Guess what? We have to have two values. So I'm going to call that u sub 1 because we know there is another value, and our other value is u sub 2, 5 pi over 6, and again, add multiples of 2 pi k to it.
Okay.
Okay? So that is what we know. Now, we are actually using, here's what's kind of cool, in section 6.5, we had this set of formulas, and here is one that's kind of interesting. We had that the sine of pi minus x equals the sine of x, and that's what we're using right here. The sine of pi over 6 could be written as the sine of pi minus pi
over 6.
This would be sine of pi minus pi over 6, which is the sine of 5 pi over 6. So we're not telling you anything new. We know that the sine of pi over 6 equals the sine of 5 pi over 6 because you know your unit circle, but this is now just confirming a formula that we already know, and this is what we were using before when we were thinking about that reference angle idea. Okay?
Okay.
Now we get to the most difficult problem that we have, okay? On this one, we have several things to think about. First of all is we have the 4x, okay?
4x.
That's not the same as anything we've done, so that's going to mean some special things to think about, all right? But the thing we certainly know is that the sine of u is positive, okay?
So that's in quadrant 1 and 2.
Okay. Now, here is what's important about that. Our u in this problem is going to equal 4x. Now, we have to think about something like that right now. Note, 4x in quadrant 1 or quadrant 2. We are going to have to divide by 4 eventually to find x. Okay, now let's think about that. What kind of angles do we have? Well, if we take an angle in quadrant 1, let's go to degrees. 0 to 90 degrees divided by 4 is going to be in between 0 degrees to 90 degrees divided by 22.5, right? 22.5. Half of that is, 20, okay. And we know that's in quadrant 1. But what about our quadrant 2 angle? Quadrant 2 is 90 degrees to 180 degrees. Okay? When we divide that, this is very bad math. I'm not writing it properly. I'm not subtracting. 90 to 180 degrees divided by 4 is 22.5 degrees. to 180 divided by 4 is 45. And guess what? That's going to be in quadrant 1. So ultimately, we are going to have answers that are in quadrant 1. But there's a strange twist to this thing, all right? You'll notice we did something that you've done before, use substitution, and that's going to come into play. So we're going to talk about the sine of our angle is square root of 3 over 2. So u is the angle whose sine is square root of 3 over 2. And so we're going to say u1. Oh, that's okay. We can draw the circle. That's fine. Okay.
And that would be the
that one
here.
Mm-hmm.
This is 60 degrees, i.e. so
pi over 3.
1/2 square root of 3 over 2.
So u1 is pi over 3 plus 2 pi k. Good. Now let's find u2. Without a ton of work, great band. Without a ton of work, we can see we know that that's 2 pi over 3 plus 2 pi k. Okay. Whoopsie. Oops. But so hilarious. But what is really happening, and this is where I love these kinds of problems, we're not talking about u, we're talking about 4x is pi over 3. So I'm going to call that 4x1 plus 2 pi k. How would we solve that for x?
We have to divide by 4.
So I'm going to, instead of dividing by 4, I'm going to multiply by 1/4 with parentheses around this so we don't forget a really critical step in this problem. And that step would be dividing every term by 4. So we get what?
Pi over 12 plus pi over 2k.
Pi over 2 times k. Notice this part of the problem changed. Okay? So if you don't do this step properly, you miss out on that. Okay, let's do the other angle.
Okay, so we've got x2, 4x2, there we go, equals 2 pi over 3 plus 2 pi k. So multiply both sides by 1/4. X equals 1/4 of 2 pi over 3 plus 2 pi k, which gives us 2/12. Wait,
or 2 goes down into 4. Let's do
so
1/6.
this is pi over 6 plus pi over 2k.
Make sure that k is not in the denominator.
It's multiplied.
Mm-hmm.
So,
and you can box it. And notice, what did we start out figuring it out? That our answers would end up in quadrant 1. And did our answers both end up in quadrant 1? Yeah, well, we know pi over 6 is, and of course pi over 12 is smaller than pi over 6. So, this is really a big test here. Being able to do this is kind of cool. And so remember that this angle that we found here and this angle that we found here, that angle was actually 4 times our pi over 6 and 4 times our pi over 12. All right?
okay.
Fun algebra.
Woohoo! All right, here's your other ET problem. Do number 2, 4, and 6. No calculators on these. They're normal unit circle values.
Mm-hmm.
Just like what we just did. All right, and what you need to bring us, one new thing you learned. Email us, one good question. None of this, what is this useful for in real life? All right.
It isn't. It's not useful. We're teaching you a bunch of stuff you never need to know again. Kidding.
That's sarcasm.
Sarcasm.
All right. 2 old skills that are important to recall, and don't forget to bring your entrance ticket to class. All right, see you later.